Hi folks, so welcome to physics. It's really great to have you all here and hopefully you're going to find this really interesting and enjoyable. We're going to start with a wee bit of numeracy today, and the reason for this is because we're going to use quite a lot of numbers and different ways of writing numbers in physics. So we won't really get to the physics until maybe after next week. But I promise you, if you really get a good grip on this, you will find the physics a lot more easier and enjoyable to do. So what we're going to do today is going to look at something called standard form, or sometimes it's called scientific notation. Some of you might have done this in maths already, so if you find this fairly straightforward, feel free just to sit through the video and just go straight to the questions. I'm more than happy for you to do that as long as I can see you are doing the work. So to get you thinking about the numbers we use in physics, I want to have a wee think at some of these questions. You can write these answers down if you want, or you can just sort of think of them in your head. Pause the video if you want, and then I'm going to sip on. Okay, so once you've done that, to give you an idea of the scale of some of those things that I asked you to think about, click on this video. I know you can't do it on this video here, so I'll post a link on the posts section of our Teams. It's a really nice video. It will give you an idea of the scale of things that we deal with in physics, from the very large to the very small. Okay, so how do we do scientific notation in physics or in science in general? So we're going to start with a really simple example, which is 100, and this is it in scientific form. Okay, so this is the process, and what you're going to find with physics is quite often it's learning the process on how to do something, and if you know how to do it, it's just a case of applying it again and again, so it can actually be quite an easy subject if you can figure that out. Okay. So let me take you through the process, and I want to practice this with the questions. So first of all, we've got the number 100, and this is it in scientific form on the right hand side. So to get the scientific form, we do the following. First of all, we figure out what the first whole number is, which is 1 in this case here. So then we put the dot after the 1. Now, what goes after the 1 is really what goes after the whole number. But because I've only got zeros there, I only need to put 1 0. If I wanted to, I could write it as 1.00. But we're quite lazy as physicists, so instead of writing out all those zeros, because remember it's a shorthand, we just need to put 1 there and we can ignore the other zeros. That isn't always the case, and I'm going to show you an example later on. But to finish this off, to get the rest of the standard form, we always write times 10, because that tells the person it's the standard form. And then we've got to figure out what the number is that goes on the top right hand side. And this is actually called the index, or the indus, if you're talking about the plural. And it tells us how many zeros there are after a whole number. If it's not zeros, it's how many numbers there are after our first whole number. So in this case, we've got 1 and 2. So there's 2 kind of numbers after a first whole number. So that's why there's a 2 there. And that's how you write 100 in standard form. If you're not sure about that, if I've gone through that too quickly, play this part of the slide again and see if you can figure it out. If you're still not sure, but you think you've got some idea, have a look at the next slide, because I'm going to take you through more worked examples. Okay, let's practice using that kind of process I showed you earlier, and I'm going to take you through 3 examples. The more we practice, the better we'll get at applying that process. Okay, so let's start now. I'm going to start by writing the answer down on the side here, just so you can see what we are aiming for. So the answer is actually 1.0 times 10 to the 3. Okay. So let's do the process. Write down the first whole number, which is 1 here. Put the decimal place after it, dot, and then check how many what numbers go after it. In this case, they're all zeros, so we just need to write 1, 0. Then we write the times 10, because that tells us we're doing standard form. And then to get the wee number at the top right hand side, we count how many zeros there are. So there's 1, 2, and 3. So it's times 10 to the 3, which is exactly the answer that I told you earlier on. Okay, if you're still not sure about that process, replay that bit of the slide just now. Okay, next example, notice we've now got 1,500. So let me write the answer down again on the side, just to show you. Okay, so it's 1.5 times 10 to the power of 3. So it's the same rules, even though the number's slightly different. We write down the first whole number, which is 1 in this case. So it's 1. Put the dot afterwards. Then in this case, we don't have all zeros. We actually have a number 5 there. So we've got to write that down because that's important. And then we can ignore the rest because they're all zeros. So then put times 10. And then we count how many numbers went after the 1. So that's 1, 2, 3. So 3 goes in the top right corner. And that's exactly the same as before. Pretty straightforward, I hope, because we're still using the same rules. Third example, if you want, you can pause the video and try this yourself. I'm going to give you the answer and take you through it just now. So just like before, the answer is 2.53 times 10 to the 3. Okay, so how do we get that? Same as before, write down the first whole number, which is 2 this time. Then we put a decimal spot. Oops, quite tricky to do it on this. Then we write down any numbers that are not 0 after it. So 5 and 3 this time. We can ignore that 0. Then we put the times 10. And then how many numbers are there after the whole number? Well, there's 1, 2, and 3. So we put times 10 to the 3, and that's our answer there, which is the same as before. Okay, now the next slide has 3 more examples, which are a little bit trickier. So I would like to try those. I will take you through the answer each time though. Okay, so can you write this one in standard form? Pause the video and then I'm going to show you how to do it. Okay, so let's do this one. I'm not going to put the answer because I would like you to follow the process. So here we write down the first whole number, which is 3. Now this one's a bit of a pain because if you look at it, we've got 2 zeros and then we've got a whole bunch of numbers. So we can't ignore the zeros in this case because there are numbers which come after it. So for this one here, we are writing really the same thing, 3.005, comma, 235. Okay, so we can't really save on any work here because there are numbers after the 0. Now we're doing it in standard form, so we do the same thing as before, times 10, and we count how many numbers came after the first whole number. So in this case it was 1, 2, 3, 4, 5, 6. So the 6 goes on the top right hand side. So really we don't save on any work there, but at least we can show it in standard form. Okay, next example, how do we write it if there are decimals in our number? Well, the rules are still the same. You are still using the same rules. So I want you to try it yourself and I'll take you through it. So pause the video and try it. Okay, so here's how we do it. Same rules as before. Write down the first whole number, which is 2. Put the dot after that whole number. And then just write down what comes after the first whole number if it's not a 0. So here we've got 1, 5, okay, and then we've got 6 and 5 here, okay. So we then put times 10. Now here's a tricky bit. We only count the whole numbers after the first whole number before the decimal spot. So here, we're only going to count number 1 and number 2. We can ignore these two because they come after the decimal point. Okay, so those aren't important. So the final answer is 2. Okay, now you might have been shown this in maths, that some people will tell you to get the original back, you count this number as many times moving down the way. So you go 1 and 2, and that will give you back the original number. So that's how we do that one there. If you're not sure about that one, replay it again. And then the final one, how do you write 2? Well, 2 is a bit of a tricky one. You might not have seen this one unless someone's shown it to you. We apply the same rules. Write down the first whole number, which is 2. There's nothing after it, so we leave it as it is. If you want, you could put a dot and a 0, and then we'd write times 10. And then here, well, this is a special case because there's nothing after 0, the 2, sorry, and it's just a single number. We actually just put 0 here. Okay, so this is a special case. You might know of it in maths. We won't really be doing these in physics, but I thought I'd show you this one. So don't worry if you don't quite get this last example. So before we move on to small numbers to scientific notation, I would like you to try the questions for the large numbers in scientific notation. There's plenty of numbers for you to practice in the question sheet, because the more you practice, the better you'll get at it. Do those first and then come back to this, unless you're pretty confident because you've done it in maths. Okay, these are a little bit trickier because you've got to think a little bit more about how to apply the rules, but the rules are still the same. Okay, so for small numbers, we use a negative to represent the number has a value less than 0. So for small numbers, it will always be point something, 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 something. Okay, so let's do this example. How do we write 0.001 as standard form, which is 1.0 times 10 to the minus 3? So notice we've got the minus 3 there to tell you that this is a small number less than 0. Okay, so the process is the same as before. We write down our first full number, our first whole number. So we write down, so the first whole number in our decimal is 1. So we write down 1. We then put the dot after it, just like before. Check if there's anything after that number. There isn't, so we're just going to put 0 there to show that. We then write times 10. And then to get the number at the top, we count how many times that 0 has to move. So there's 1, 2, and 3. So that means there's a 3 there. And then we put a negative there to complete it. Okay, so just to show you, the dot goes after the first whole number. Okay, I'll rub that out so you can read that a wee bit better. And then in this, how many places the dot has to move. So it's moved 3 places. So it's 1, 2, and 3. Okay, wee bit trickier, but the rules are still the same. Okay, let's do an example. Let's do, how do we write 0.003 in standard form? So let's put the answer on the side here so you can see what we're aiming for. So it's actually, oops, if I can do the dot. I'm afraid my board's not that great. 3.0 times 10 to the minus 3. Okay, so same rules as before. We write down the first full number, which is a 3. Is there anything after it? Nope. So we put the decimal point down and write down 0. Then it's times 10, because that tells us we're writing standard form. And we count how many places we want the decimal to be. So there's 1, 2, and 3. So there's a 3 there, and there's a minus to show it's less than 0. And we can see we've almost got the same if my handwriting was a bit neater. Okay, next one. How do we write this 0.0036 in standard form. Have a go of it yourself before watching the answer, so pause the video and try it yourself first. Okay, hopefully you got the answer 3.6 times 10 to the minus 3. If you did, give yourself a wee clap on the back. If you're not sure how we got that, I'm going to take you through it just now. Same rules as before. Write down the first whole number we come across. So that's 3, because remember we're going this way every time. So it's 3, 3, put the decimal place down. Is there any number after 3? Yes. So we've got to write that down. So it's a 6 times 10 now, because that tells us we're using standard form. Now, how far did the decimal place move? So let's count it again. We went 1, 2, and 3, because remember it's after the number 3. So we write 3 down there and then put a negative to show that it's actually less than 0. And you can see that's how we got our number there. Okay? Now, if you feel confident having seen those two, by all means go and try the questions in the question sheets. Again, plenty for you to try. If you're not sure, I'm going to show you a few more trickier ones just to give you a bit more practice. So how do we write 0.0392 in standard form? Okay, so I'm going to go straight into it. So same rules as before, as always. Write down the first whole number you come across. So that's 3. We put the decimal point down after that. Are there any numbers after 3? Yep. So it's 9 and 2. So we put 9 and 2 after the 3. Then we put times 10. And how many places is the decimal place now? So let's count it. It is 1 and 2. So the 2 goes there, not all the way to this 2, just to after the 3, remember, because that's where we put our decimal place. And then it's a minus to show it's less than 0. Okay, so the answer there is 3.92 times 10 to the negative 2. Okay, next example. How do we write this one in standard form? Try it yourself, pause the video, and then I'm going to show you. Okay, hopefully you didn't get caught out. This is not a number less than 0. It's actually a large number. So we still use the same rules though. So we write that. So hopefully you got the following as your answer. I'll give you this in case you try this yourselves. So 3278 times 10 to the minus, no, not minus, sorry, almost got quiet myself, to the power of 3. So notice there's no minus because this is not less than 0. It's exact same rules as the one we did for large scientific numbers. So if you didn't get it, let's do it together. So write down the first whole number, which is 3. Put the decimal after it. Are there any numbers after the decimal? Yep. So we write down 2, 7, and 8. Then we write down times 10. How many numbers were after the 3, or how many places did that decimal have to go? It was 3, because there's 1, 2, and 3. So we put 3 there, and that's our final answer there. Okay, so if you got that, give yourself a wee clap on the back.